Welcome back to Across the Opti-Verse, where we didn't find enough technical podcasts that we enjoyed, so
we created our own.
My name is Audrey.
And I'm Dean.
Today's episode, Dean will be interviewing one of our enthusiastic colleagues, Daniela Ghersevich.
Yeah, so today's episode is really, really great. We actually got to sit down with Danny and speak about really what it means once you've got your engineering degree and transitioning into an engineering environment.
What happens in real life?
What happens in real life?
You've got the degree and now you're out in the big wide world.
Yeah, and talking about her passions in software and hardware, and also some of the projects she's worked on, the lessons she's learned along the way. And I think most importantly, just that welcoming into the professional life, what might be a trial by fire, but becoming a professional and working and actually seeing real life problems get solved with real life engineering.
Yeah, you always have those projects and assignments every year, and in your final year in your engineering degree, in your science degree, anywhere in STEM. It's a big part of your studies. It's a big part of how you feel when you graduate. The pride that comes along with it when you walk away with that, and then you step into the working world. And if you've hit the jackpot, hopefully you've stepped into a working environment that's encouraging and supportive. And that's largely what our grad academy is there for. It's that stepping stone where we need these young graduates to step up a little bit professionally, but in the most supportive environment that we can find. And then not really throwing them into the deep end, but I think for anyone coming out of varsity, it's a trial by fire. And Danny, having experienced your conversations with Danny and my own conversations with her, she's so enthusiastic about these lessons that she's learned in this path that she's been walking. And there's so much that we've learned about the projects also through her and like her perspective. So it's going to be really fun.
It's a great episode and I'm so excited for you guys to watch it.
Thanks, Dean.
Thanks, Audrey.
And for the viewers and the listeners out there, you can find us anywhere where you find your own podcasts. Thank you.
Cool. Let's jump in. If you would like to jump to certain parts in the episode, at 3 minutes and 45 seconds, we talk about Danny's journey from graduate to consultant. At 8 minutes and 30 seconds, we talk about the power of code generation. At 17 minutes, we talk about adopting the model-based design workflows in an established project. At 25 minutes and 10 seconds, we talk about how we work in real-life engineering problems that go beyond the textbook. And finally, at 29 minutes and 15 seconds, we close off with talking about how we navigate the software engineer's path. Hope you enjoy. Welcome, Danny, to Across the Opti-Verse. We're so happy to have you here. Thank you, everyone, for joining us today. Today, as I said, we've got Daniela Ghersevich with us. She studied electronic and electrical engineering at Stellenbosch University. She did her final year project as a solid state switch for smart grid control, and has a real passion in control systems, hardware development, and we've been speaking a lot, real strong interest in working in the renewable energies field. So Danny is a consultant in the software engineering department, has been with us since the February of 2023, came through our graduate program. So Danny, thank you so much for joining us here. Maybe first question right off the bat, talk to us about that transition from a recent graduate in engineering, into working into software engineering in a design field.
So thank you so much for having me. It's very exciting to talk about these things. So I obviously, like you said, I graduated at the end of 2022. In electrical and electronic engineering, which was a great feat for myself. I really struggled with varsity. It wasn't easy, and so transitioning to something new was nerve-wracking but also exciting because it felt like a new beginning. I started at Optimum in Feb 2023, and it was just uphill and downhill all the way, but we learned so much. So I came from a position at university, like I said, it was a bit of a roller coaster for me, where I feared software development. But then it was a lot it was a lot different.
Yeah.
I was given introductions into MATLAB, how to use MATLAB and Simulink properly, whereas varsity we didn't learn the fundamentals. We didn't have any courses. We were told, go forth and conquer MATLAB. So it was a lot better when we stepped through it. I think that opened my eyes to what software development can be like, that it doesn't have to be this big thing that you have to, conquer all at once, but you could do it a bite at a time. So it was very interesting. And I mean, it's nerve-wracking, I think, for most people starting their first job. Obviously, I'd done a bit of VAC work throughout school and varsity, but your first job, you have all these responsibilities and you have all these expectations for yourself that maybe other people aren't expecting, but you want to achieve things and you want to do those things. So that was interesting, trying to figure out who I was in this like workspace. But it was incredible. We had so much exposure to what we could face in the sort of software development environment that Optimum works in. And we did everything and anything. We did financial like analysis. We did model-based sort of design Simulinks things. So we got exposure, and then when in August of last year, when I moved from a graduate to an actual consultant in software development, it was a completely different experience, because now you really have responsibility. And I think I was challenged. I had things that I had to start doing. I was put into a project that was developed and it had been ongoing for a year, and they were towards the end phases, and I was told, we need you to generate code from this script, this model we've created in MATLAB. And I had no idea what any of that meant. I had worked with code generation like in my scripts in my final year project briefly, but I had no sort of knowledge of what was expected from me. So I did my, I suppose, on-ramp of the project, and then I had quite a few challenges. That it was tough. There were things that made sense, things that didn't make sense, things that were working 1 minute, things that weren't then not working the next minute. So that made it more difficult. But I think, and what my motto last year was, as long as you try, whether it's a good outcome or not, there's something you learn from it. So that was a very, very interesting experience, and I'm super grateful for the experience that I had last year. And I mean, I continue to learn all the time. And I've had the opportunity to work with such knowledgeable people. So it's been amazing.
No, it's awesome. I mean, there's so much there I'd love to touch on. I think we could spend just hours talking about it. And I know we already have spent hours talking about it. But I think the important part of it is you talk about code gen. I think code gen's a topic that comes up a lot. Maybe just dive deeper into what is code gen.
Okay, so code generation is basically conversion of a MATLAB script or Simulink model into other sorts of code, so into other code languages. So for example, C++ or HDL code. And the main purpose is that you can take that MATLAB and Simulink code or Simulink model and then use it in other languages and use it for other purposes. So for example, HDL, you can then use it on FPGAs, where prior to it you had to, you designed whatever you required your model to do, and then you had people actually writing the HDL code, which is quite a niche skill. I, for myself, do not have any experience writing HDL code because it's quite tough, and FPGAs are renowned for being difficult to work with. So it allows that seamless conversion without the manual coding, which then in any sort of project, it reduces human error. Because when a human being is doing something, there's most likely going to be human error, and that's where you have bugs and things that become not only time but also financially costly at the end.
Yeah, it's kind of understanding this whole, the traditional methods was create your algorithm, your innovation, design it, make it work in one environment, and then having to convert it to the next environment became quite a time intensive, costly process. And so now, with CodeGen, you can do all the cool stuff, and with some sort of a click of a button, really, interoperability of your code, your language, your model can just be converted into something that's understood by an FPGA or various pieces of hardware.
Yeah, STM board, microcontrollers, even just a C Windows environment, DLL or something like that. So yeah.
Okay. And have you seen the effects of, let's say the positive effects of that quick CodeGen stage?
Yeah, we've done work with clients that have asked us to sort of demonstrate the use of code generation. And it's been amazing because, like I said, the continuous issue or the reoccurring issue is that people are having to write this code by hand. And so that is one positive thing we've seen, is that someone like me could take a script in MATLAB and convert it to HDL code and know not one thing about HDL code. Obviously understand certain aspects of it, but not the fundamentals of how to write in language. And so that time, just, one, resources, you don't need people skilled in those niche things, but also it's a lot quicker.
Yeah. And you can have confidence that what you've code-genned actually does what it's supposed to do.
100%. MathWorks is confident, I suppose, that their code generated is up to standards and efficient.
Yeah.
So
yeah. No, that's brilliant. I mean, I think that's a really cool part, and I know we've got a lot more to talk about, but I also wanted to just talk about, whenever we've discussed outside of this, you always talk about your passion for designing something and being able to develop it on a hardware system. Maybe let's talk about that a bit more. What kind of ignited that passion?
It's strange. So, like I mentioned earlier, my fear of software development sort of, I was in this not industry at the time, but I was going to be in this industry that was divided into two sections. You either were working with hardware or you were going to work with software. Yeah. And I just, like I said, I had a fear for software. So hardware was the way to go. But then when I actually worked with it in varsity, when we had to design our little game using hardware, yes, it had also software components, but we had to design Space Invaders, and then we had to create a battery charger using a solar panel and stuff like that. Those things ignite and excite, I think, well, for me at least. And as soon as I had to use my soldering iron, and like with my final year project, I had to sit under a microscope soldering these components because they're so small. Yeah. And I think it was things like the fact that, circuit boards were so big, and now they can be as thin as paper. Yeah. Those sort of things excited me. I was like, I want to be part of that. So when I signed up to study study electrical engineering, one of the departments within E&E at Stellenbosch is energy. Okay. And so I was like, oh, that's exciting, and that would involve hardware. So I think it was a culmination of things, but yeah, I just wanted to be very hands-on. The idea of sitting behind a desk, typing on a computer, which happens to be a lot of what I do now, freaked me out a little bit. Yeah. But now I still love the hardware. And actually, being a woman in engineering is not as rare as it used to be, but it's still rare. Yeah. But someone that actually wants to do hardware, everybody wants to do software. Yeah. I mean, the luxuries of, I suppose, being a software developer, compared to, having to go in and use oscilloscopes. But so then knowing then also that I was like unique in that way excited me, because we need still people that work with hardware. Yeah. That's, I suppose, how it's lots of different things that
Yeah.
came to be this. Yeah.
Look, the exciting thing when you mentioned actually soldering and working with your hands, when I started engineering as well, like I had this idea that I'd get my hands dirty from day one of working, but I don't have access to that. I've followed that software path. I really enjoyed that software path. So it's always nice to hear an engineer getting their hands dirty, getting into the design, the building of it. And that's really great that you've got that passion in it, especially also in the energy section of Southern Africa. Energy is a problem.
Yeah.
And having people with the passion to try and come up with the solutions and solve it with innovative ideas, that's amazing.
Yeah, no, it's incredible. And I think it's, you know, I did think, oh, maybe I should have been a doctor, and then I went job shadowing. I was like, nope, not for me. But knowing that I could make a difference, you know, I think engineers in general make a difference every day, but knowing that was something that I could do to make a difference, but at the same time not be harming the environment.
Yes,
because it is, I'm a big recycling, you know, save water person. So I like to consider those things, be considerate of those things as well. So then knowing that I could hopefully make a difference in that way also excited me. And I mean, it still does.
Yeah.
Yeah.
No, and I think maybe this is a perfect time to transition into kind of the projects you've been working on. As you say, I like it also. It makes me feel good that, you know, engineers, one of the things is to try and make life better for people, even in small things, major things, but also at the same time doing it environmentally friendly, consciously. A lot of the traditional kind of design projects work in, it is quite it's a very long, I want to say clunky process. What was before to what it is now. And there's been something that I've discussed with a lot of people. I think I discuss it probably 3 or 4 times a week with a client, is this concept of model-based design. Maybe, you know, we can start off there. It has so many definitions, but to you, what is model-based design?
So model-based design is, for me, exactly what that says. It's designing using models. So having a model for every step in the design process.
Yeah.
So yeah, it's a process that brings together various different processes that are part of design into one sort of thing that, you know, can be intertwined and people can work together. Yeah.
Like a singular environment where you can
Yes.
trace back every decision to, you know, why does this do this because of that physical system there and that physical system there. Amazing.
Exactly. And also I think another important thing about model-based design is that it is an environment that you can work collaboratively with other people, but at the same time not negatively influence. So you're not changing one thing that affects the other person's whatever they may be doing, because obviously in a design process there's your mechanical engineer, your electrical engineer, your systems engineer. So you can all work on your individual things with being able to see what the other sort of engineer or person is doing, but also your design not affecting theirs directly, in such a way that, you know, 1 minute it's working, the next minute theirs isn't working. So you can work modularly but together.
Yes.
If that makes sense.
Yeah, so that I think the core of any successful project, anything really, or from what I've seen, is that collaboration. Yeah. You can work individually on what you need to do, your task, your specific deadline, but at the same time ensure that you've got that collaborative nature between various other kind of influences and collaborators on the project. That's amazing.
Yeah.
And kind of let's talk about it in when you came to the concept of model-based design. Was that right at the start of the project, or where in the project did that kind of start coming up?
Okay, so let me speak quickly to what the project entails, and then I'll speak to that. So I'm working on developing a medical device.
Yes.
So obviously there are specific standards we need to follow.
Sure.
Because human safety.
Yes.
You know, and I think that comes with, I mean, a lot of any design sort of process, there is some sort of safety aspect to it. So initially, there was no from my point of view at least, there was no real intention to follow a specific model-based design workflow. But then throughout the process, it just made sense.
Yeah.
So what a traditional workflow looks like is you have your requirements, your specifications, and then you design. Then once you've designed, you implement and test.
Yeah.
Whereas model-based design is you have your requirements and then you have your model.
Yeah.
So that includes specifications, design, etc. And throughout that whole process, you are able to test.
Okay.
So it made sense for us to test as we went along, but also to follow certain of the model-based design workflow that Simulink or MathWorks tools have to offer.
Yeah.
And then that's when we sort of realized we were on the models-based design path.
Yeah.
Maybe we didn't follow it, as the workflow is shown, let's say on MathWorks website, but it's got a model-based design backing because we building the models and then we're testing. And now we're at the deployment stage, in which case we're still testing, obviously,
yes.
But we're able to deploy onto STM boards.
Okay. That's awesome.
Yeah.
So it's a continuous testing throughout.
Yes.
That's
So
really cool.
so how it works is your testing can be divided, for example, into control, which is developing a control system, which most things need. Then you can have your integration testing. So that's, you have models of, let's say you're designing an airplane. I don't have any clue about designing airplanes, but let's say you're designing an airplane. Then you can integrate the engine and integrate the actual wheels moving and stuff in a model. So you're not actually attaching the engine, but you have a model in Simulink of that engine.
Yes.
And then you can test how your control system and that integrate and if they integrate correctly.
Yeah.
And then once you've done that, then you can start integrating with, hardware. So whether it's your actual engine or something that can represent if your signals are working properly or not.
Yeah.
And that's called hardware in the loop testing, where you integrate with hardware. So it's divided into, that's sort of the process we've taken, is control, integration, and then hardware in the loop testing.
Brilliant.
So you're testing throughout the whole process.
Yeah.
Which means if you find an error in your control system, which happens, I mean, you miss something, it's supposed to not do that when this button is pressed, but it does go into that state when it's pressed. Then well, that shouldn't happen. Let's fix that.
Okay.
Instead of you getting to the end of the process, you've coded up your software, deployed it on the hardware that you're using, and then all of a sudden realize, oh goodness, now this doesn't work, and now we have to go back and fix those bugs. At which point you have spent money.
Lots
time.
of money and time on it.
So
so cool. That's awesome that you're able to continuously test. And what I think I find really interesting is that without intention, you've fallen into that model-based design process. When the project is, I think you said it was a year old, it's quite established, you were able to fall into it and see the positive effects right away.
Yeah, so I had, the project I initially worked on was more software based, and then I moved into the hardware. Well, this basically designing, building this medical device, and that's when it just seemed we have the tools. We have the Simulink tools to do it. So we were like, that makes sense to do it that way, because we had seen issues from like previous devices, is that you get to the end and now you want to start implementing a new piece of hardware, and you have to go back and change everything that has been developed already. Whereas we wanted to develop it in such a way that it can be changed modularly. If I want to change one specific thing, I can change it and it doesn't affect the rest of the system.
Yes,
yeah.
So that I think it's called CI/CD, continuous integration, continuous development.
Yeah.
You're continuously allowed to improve, optimize your system, whatever it may be in the design process. And you can continuously test that it works. And once something works, you can integrate it into the solution without having this fear that it's going to break
what
1,000 different pieces. Yeah. Oh, brilliant.
And then that means, you can stay up to date. Like
Yes.
technology is always changing.
Mm.
And that's an important thing, I think, with any engineering company and engineers in general, is we have to continuously learn because stuff is continuously changing. I mean, look with AI.
There's a lot.
Everyone's now fearing their jobs, but
Yeah.
you have to work with it. If you're going to work against AI, then
Yeah, no, that's exactly it. Maybe let's talk about, with every workflow, every process, when you get into the thick of it, the real life, not outside of the textbook, their challenges and their obstacles. Maybe in the project work that you've done, what has been, and maybe in that model-based design process, what's been the biggest challenge? What's the obstacle?
I think one of the biggest obstacles for us specifically in this project is we didn't, like I say, follow the model-based design process from how, I suppose, the textbook case of model-based design. And that made it so, for example, we obviously designed around requirements, but we didn't do the requirements first. And that made it challenging because there was a lot of chop and change. We'd design something and then be told, no, that doesn't match requirements, so that's not how it looks. Go back, have to redesign it. So that took a lot of time, and I think it in itself you're learning a lot because you're redesigning something 4 times, but it takes time. So that was one of the challenges. At least for me, I would get like a little bit frustrated that I'm redesigning something that is probably known, but it's not necessarily specified from the beginning. So that was quite a challenge. I think with software development and even model-based design, is software is always unpredictable. And so you think things are going to take 5 minutes and be super seamless, but then when you actually get to it, it takes you a lot longer. And something so simple, like one little setting in the STM IDE that you didn't change and now your thing's not working. And you can spend hours trying to solve the issue and you don't know. So that was a challenge for me. I think it's very much, engineering is obviously problem solving. And you're problem solving all the time, which makes it fun and keeps you on your toes. But so those are a few challenges I experienced. Also just things not working the way you expect, having to go with plan B, C, D, E, F, G, it's just one of those things that I think varsity, you don't really get exposed to that. But in a work life,
happens.
Things don't go your way always.
And you become very good at planning for plan B, plan C, plan D. Oh man. Maybe I think something to close it off is maybe let's talk about where you're at now, reflecting on everything you've done. What are some of the key lessons, the key takeaways from model-based design and in general the work you've done?
So in general, software development isn't out to get me. I think that was the biggest learnings of last year, is that if I put my mind to something, and I think it's important for everybody, if you put your mind to something, even if it seems super challenging. Yes, I'm no software developing pro, but it's better. And how you view something completely changes how you handle something, and how you deal with it changes how difficult it becomes. So that was a big thing for me. And I think overall, just learning that there's value in these tools, and there's value in your abilities. Same with model-based design. It's a very valuable tool that can be used in most industry. I mean, you can use it in automation, you can use it in medical device development, you can use it in telecommunication, you can use it in other embedded hardware development, stuff like that. So there's a lot to it. And I think another important thing is that you never stop learning. There's a lot to everything. You might be using a normal development workflow, or your project development workflow, or product development workflow rather. But model-based design can be super useful if you try it, even if it's new and unfamiliar. So I think just stepping out of your comfort zone.
I think that's important. I think that's a lot of, particularly coming straight out of university as a graduate, You've been given all these skills and these tools. You have no idea where you want to go, how you want to use them. And I think I remember for me, work was scary. I was like, this is something, when I was a child, grown-ups used to do, and I was just in school learning. And then same with university. I'm still learning, I'm taking this all in. But since I've been in this position, and I think you're in the same boat, is that it is scary. Put your mind up to the challenge, find solutions to problems, and learn throughout the process. I mean, what I've probably learned in the last year alone about model-based design and about a few other topics, it has made me, I feel the better for it. At the time, I was like, I don't want to learn about this. This seems way too complicated, way too scary. And I'm so glad I kind of got over myself. And I kind of just learned, and I talked to people. And I think, seeing you go through that process is also motivating to me. It's that we're all in this together, and we're going to really be innovative, do something different. Particularly, it's what we at Optimum like to do. We like to work in projects that really make a difference and really add value. And I think you are doing an amazing job in that project. You're really making it a lot of fun to talk to you, at least.
Thanks.
Yeah.
Yeah, it's been a lot of fun, and that's exactly it. I think my dad always says to me, he's not too young to learn. And I mean, let me not expose my dad on a podcast, but yeah, he's not too, did I say too young, too old to learn.
Yeah.
And I think that's important. I think there's so many things available for us to try, and yeah, it's an exciting life we live.
Yes, it is.
Make the difference where we can.
Oh, that's amazing. And I think it's a perfect way to end off this episode. So, Danny, just thank you so much for joining us. Really excited. I say excited a lot because I truly am excited about this whole thing. But thank you so much for sharing your journey and your insights on transitioning from a graduate and also kind of working in this model-based design environment, working in software, working in hardware. I think it's amazing to see in your 1 and a bit years of working experience, everything you've engaged with, interacted with. I'm like truly amazed, and I'm jealous, and I want to learn more, and I'm going to talk to you a lot more after this, but you really show the amazing value and the benefits of someone motivated that can just do crazy, cool things. And so we're so grateful for you joining us today, and we look forward to talking to you in later episodes on different topics.
Thank you for having me. It's been fun to talk about.
Amazing. Cool.